Hello everyone, I'm Mike Bravo with RUClabs, and today we'll be discussing critical cybersecurity threats that can affect our road user charging infrastructure, things like toll roads, bridges, and tunnels. So if you manage a toll road concession or you're a bridge and tunnel operator, then you already understand the importance of these essential pieces of public infrastructure for moving people, goods, services from A to B. But with the addition of newer and smarter technologies for road user charging, you're also directly responsible in a way for the collection of massive amounts of information from the drivers on your roads. So you have the mandate not only to keep the traffic flowing and to collect revenue, but also to protect the privacy of your road users. And let's face it, unless you're managing an antiquated barrier-style toll booth, collecting coins, really you are, in a way, harvesting data that describes not only the identities of vehicles and their owners, but sometimes even their passengers as they're crisscrossing on your roads. So with that in mind, what is the cybersecurity threat landscape that we face in road user charging today? We hear about ransomware attacks, malware hacks, but really our attack surface, our vulnerability is truly expanding exponentially. We are no longer simply defending our IT infrastructure against local attackers. We are seeing sophisticated hacks from global state actors, and really more and more our new security challenges are coming from adversarial AI agents that are trained to exploit vulnerabilities. Now, in part, this growth in cyber threats has to do with the exponential growth of artificial intelligence over the past 18 months or so, but it also has to do with the evolution of our tolling infrastructure. We are evolving rapidly from passive sensing devices and cameras to start using all-in-one smart edge devices. And these newer devices often are AI-enabled, things like license plate readers, LiDAR vehicle identification systems, high occupancy of vehicle detection systems, and IoT devices. And more, these are powerful pieces of equipment that are incorporating compute, networking capacity, full operating systems, really to the point where our roadside hardware, the things in our gantries, are starting to look more like mini roadside data centers with real potential vulnerabilities. Now, we can break down our road user charging systems into three discrete tiers. We have the roadside edge devices, our cameras, sensors, RFID tag readers, things like this. And we have a mid-tier of concentration systems, things that are receiving data from the edge and processing them. And then, of course, we have back-end systems for billing, for CRM, monitoring, governance, compliance systems, things like that. And at RUClabs, we analyze the resilience and security of tolling solutions in these three tiers according to what we call the 5 Cs. That is, how hardware, software, and processes capture roadside data from multiple different types of devices, how we can coordinate these devices to ensure that the information we're collecting from cameras, from LiDAR, from tag readers, all correspond to the same vehicle. And since we often have multiple redundant devices on the road. We also need to have consensus to reconcile when we're talking about the same vehicle and not duplicating information. And then there's a calibration element so that we can ensure that the data we are collecting is both accurate and synchronized with other data. And this synchronization is really important, among other things, for collating security information. And finally, the configuration aspect, which refers to those steps we are taking to harden edge devices and to have the ability to re-provision these devices quickly in case there is an attack or some sort of data corruption. So this is our methodology at RUClabs. We are systems integrators specializing on road user charging solutions. Our focus is on integrating diverse hardware and software solutions. So we are manufacturer agnostic, and we work with these 5C challenges to help tolling concessions integrate new technologies, stay safe, maximize uptime, and ensure recoverability in case of a disaster. And so with these 3 data tiers in mind, right? Roadside, connection, and back office, and the 5 C's of capture, coordination, consensus, calibration, and configuration, let's dig into some of the top cybersecurity areas of concern and how we can protect ourselves from attack. So let's start with IoT and edge device security issues. I'm sure many of you are looking at or have already implemented some of the newer all-in-one type devices. You know, cameras, tag sensors, vehicle detection systems that incorporate onboard intelligence. For example, cameras that might have built-in license plate recognition, AI subsystems, OCR systems. And these devices, while incredibly efficient and powerful, do introduce many new potential vulnerabilities and exploits. And this is simply because we are deploying hundreds or thousands of these devices along a stretch of highway spread across multiple gantries and sentry points. And because they are in reach, both physically and electronically, by a mixed group of maintenance personnel and, in a certain sense, even the general public, they represent potentially our most exposed entry point into our networks. By definition, all these devices require bidirectional communications. So this is where we see key issues like weak encryption, infrequent firmware and software updates on the devices, a lack of proper network segmentation, inadequate identity management with multi-factor authentication, and of course, problems just related to misconfigured services, things that are insecure because of their default configurations. Even worse, some legacy type devices, some maybe non-IP, non-network devices where we've added a network adapter. You might be familiar with Modbus controllers that are used often on backup power generators and gantries. These lack proper AAA capabilities. This is authentication, authorization, and auditing, and therefore can be accessed and utilized pretty much by anybody who has access to the underlying IP network. So think about it this way. If I can access a network where old Modbus adapters are attached to electrical power generators, there's really nothing restricting me from stopping and starting the generator, or even sending instructions to run the generator at speeds that could cause physical damage. The point is, many devices that we have out in the field today simply do not integrate easily with our identity and secrets management platforms. They don't support modern multi-factor authentication, and they present networking and configuration issues that can create vulnerabilities for our overall tolling infrastructure. And then there's the question of physical access. Now, roadside equipment is often stored in locked equipment cabinets that are accessible many times by a common set of keys. The problem here is that it only really requires one rogue field service technician to make a copy of these keys and render all the cabinets on our road vulnerable. And aside from, the obvious vandalism potential or theft, this physical vulnerability leaves us open to more surreptitious attacks. For example, someone installing a land turtle in a gantry that could quickly compromise our network. Now, a land turtle is a small device that, when plugged into a network switch, in this case a gantry switch, can enable outside access to our network, overriding our other network protections like firewalls. So if we implement electronic locks and sensors, maybe with access codes that can be centrally managed in our secrets management platform, not only can we provide a better defense against physical vulnerabilities at the roadside level, but these electronic locks can also promote better auditing, better accountability. So for example, if we were to find a land turtle or some other anomaly in a gantry cabinet, we could at least be able to track down which technician had access most recently to those devices. In a data center, we set up all kinds of multi-form factor authentication. We have badges, biometrics, maybe we have a man trap to control access. But we can't really add these levels of controls into roadside equipment. And like I said earlier, given the added complexity, in many ways, our gantry cabinets are becoming like mini data centers. And at a minimum, we can introduce electronic locks and camera-facing toward the gantries to improve our physical access security. So with these types of problems associated with the complexity of new devices on the roadside, right? Identity, network configuration, encryption, physical access. This really brings us to the importance of what's called the zero trust model. Basically, with the zero trust model, what we are saying is that we should not trust by default connections between devices. We need to authenticate all accesses and be able to audit these connections. So essentially, gone are the days when protecting our perimeter with a firewall could be considered sufficient security against attacks. In other words, with a zero trust model, every component is untrusted by default. This includes not only our servers, ensuring that they have proper authentication, authorization, and auditing, but also our network switches, cameras, and roadside sensors. And by controlling these devices within a zero trust model, we're able to limit any kind of lateral movements from one compromised device to another, effectively breaking the kill chain in the eventuality of a cybersecurity breach. Once again, this is necessary because of this expanding attack surface. So if identity and secrets management is a necessity on all three tiers, then access restrictions and logging should not just be limited to our servers, but also to our backup software, our software monitoring tools, and really any kind of web service endpoints. Unfortunately, access security to critical services is often ultimately defined by security through obscurity. In other words, we tend to consider systems to be secure because only a handful of concession veterans actually know how they work. But of course, security through obscurity is really just a legacy of bad documentation. And maintaining a central repository of up-to-date live documentation of our critical systems is in itself fundamental to our disaster recovery plan, right? If we need to rebuild compromised systems quickly, it will only be possible if we have good documentation. Next, we have the question of vulnerability management. So every day, hundreds or thousands of new software and hardware vulnerabilities are identified in the world. And some of these vulnerabilities apply to equipment in our tolling systems. Most of them don't, but some of them do. And if our systems that could be affected by these vulnerabilities aren't properly maintained and patched, then this can become an entry point for an attacker. And again, the thing to remember is that attackers now oftentimes are adversarial AI agents. So they have access to the same vulnerability catalogs that we do. And if we're running outdated software or unpatched hardware, then this could be an entry point for malicious actors. Addressing this requires regular vulnerability assessments and prompt remediation, because the more services, the more components, the more subsystems, the more virtual machines, processes that we have deployed in our road user charging environment, be they in the cloud or in our data center or spread along the highway, the more potential vulnerabilities that we are exposed to. So it is an exponential problem. We could say in the old days, it was considered sufficient best practice to simply set up a centralized syslog and collect security logs from our devices. But these days, with the immense amount of data, we really need advanced tools to keep ahead. We need to be able to collate and filter all the security alerts from all of our devices. And more importantly, we need to be able to assess and prioritize vulnerabilities according to their probability and potential impact. Now, for vulnerability management, there are plenty of one-size-fits-all tools. But many times these tools tend to be expensive and, more importantly, difficult to shoehorn into existing IT ecosystems that are very specific, like road user charging. And so what we recommend is to integrate multiple tools that do a better job, if possible using low-cost open source solutions, and building a cohesive dashboard and a priorities engine that essentially allows us to create a vulnerability prioritization funnel. And it is from this funnel that we can create an automated vulnerability scorecard to quantify vulnerabilities across two axes. The vulnerabilities that are the highest probability of occurring, and those which have the highest potential impact. And finally, I'd like to address what, let's call them exotic attack vectors. You know, when we think about cyber threats, we tend to think of things coming in from the outside, from the internet, or maybe attacks over our network. And these kinds of things we can monitor for with software probes. We can do all kinds of things like pen testing. We can use CM and XDR tools, all kinds of things for hardware remediation on different devices. But in fact, as a tolling concession, we're collecting images and signals of all kinds. And also in the near future, we'll be collecting more and more vehicle-to-vehicle communications and vehicle-to-road communications. And so it is with this that we can think about things like adversarial images. So this funky-looking shirt I'm wearing was created by German artist Simon Wickert. And this is what's called an adversarial print. And it was specifically designed to confuse object recognition algorithms in models like OpenCV and YOLO. So essentially, when I'm wearing this shirt, many AI image subsystems will not recognize me as a person because of the confusing of the image. If Simon can confuse AI image recognition with the shirt, could someone not do the same with a plot or an image on a vehicle? Now, aside from simply avoiding toll payment, the real danger or consideration here is that adversarial images could potentially be used to not only confuse image capture systems like our automatic license plate reader or PTZ video cameras, but maybe even execute malicious code. So this is an old image. I'm sure many of you have seen this before, but the idea here is that we're not just capturing images, we're capturing them and processing them. And that processing could lead to some unexpected and undesired consequences. And could this also be done with other types of devices, with RFID readers, with LiDAR systems, with 433 megahertz weather stations, or tire pressure monitoring systems, all kinds of things. We are adding so many different tools roadside. Even audio can be a thing, an attack point. In 2016, certain Mazda vehicles had a bug in their sound and navigation systems that if they were listening to a certain radio station in Seattle or even a certain podcast, it would brick their system and it would stop functioning. Now, this was an unintentional bug in the Mazda sound system, but it illustrates how data input or exchange really goes beyond our idea of data packets coming in over the internet. And the truth is, the internet is full of examples of Bluetooth exploits, many of which can be used to attack vehicles. We hear more about things like GPS spoofing and software-defined radio hacks. And while these types of attacks might not be top of mind for us today, as sophisticated self-driving vehicles become more ubiquitous, these type of exploits are going to become a bigger problem. Because in a way, the data bus, if you will, where cars and trucks are connecting with information is literally the highways that they're on, the highways that we are operating. And so I get it that some of these exotic attacks might sound a bit far-fetched or unlikely, but they're really meant to illustrate the point, which is if your tolling concession is capturing images or signals of any kind, then you really can't consider your environment to be air-gapped from the world, right? Air-gapped, this idea that if our systems aren't connected to the internet, then we're safe from attacks. But let me just dispel this myth. While your roadside devices and back office systems might not be directly accessible from the internet, your tolling systems of all kinds need some way to receive data from the outside world. You need to receive software and firmware updates to allow third-party maintenance personnel to access to fix problems. And then you also need to be able to access SaaS ticketing platforms or asset management tools, or to update antivirus and vulnerability tools. So you're never completely on premise. And your systems also need to be able to send data to Department of Transportation to share accident videos and reports or tolling violations with customers and with authorities. And so these are different ways that we're not air-gapped. You know, if we're operating a nuclear power plant or a hydroelectric dam, then okay. Maybe to a lesser extent if you're running an air traffic control oil pipeline, but you cannot consider a modern tolling concession as air-gapped. In fact, you are exposed to the maximum extent. You are a high-profile, highly visible target. So public tolling concessions, tunnels, bridges, are really as exposed as it gets, because nearly anyone can drive through your installations with all different kinds of signal processing equipment. And again, add to that the new internet of billions of intelligent agents, which are undeniably here to stay. And the result is that inevitably your tolling concession needs to have a mechanism for secure remote access. Secure remote access, or SRA, is something that will allow external vendors access to your equipment in a controlled and secure fashion, respecting discrete time windows, with multi-factor authentication, and the authorization for someone remotely to connect only to a specific system on your network. But these systems also bring a whole new level of auditing. We can potentially require somebody on premise to be following a remote connection, following keystrokes, and in a mirror session, and even recording this remote session. And SRAs also allow us to have bastioned software repositories. This is where anything that we need to bring from the outside into our environment can first be analyzed, checked for viruses, using checksums and hashes to make sure that the software that we're uploading corresponds to the original code and hasn't been modified in transit. With all this, it's worth considering what are the intentions a cyber attacker might have. These could be commercial, right? Ransomware. They could be disruptive as a form of cyber terrorism. Attacks could be experimental, someone testing the limits of their abilities. And with autonomous AI agents, attacks might simply be inadvertent. We just got scooped up because of known exploitable vulnerabilities that we have. And there's an entire global marketplace of these newly found vulnerabilities, or zero-day exploits. There's a great book. It's a bit outdated, but worth reading, by Nicole Perlroth, called This Is How They Tell Me the World Ends. And in it, she provides a chilling description of this burgeoning marketplace of zero-day exploits, and really gives us a bird's eye view of what we're up against. I tend to think about it this way. The potential of AI and AI agents is extraordinary and really difficult to calculate which things will end up being beneficial and which things might become adversarial. And AI agents, in combination with decentralized technologies or with crypto, can also open up all kinds of really interesting new privacy-preserving business models, but also with potential destructive outcomes. And AI agents plus crypto plus cyber weapons, well, this could be a real game over scenario for us. But without dwelling on apocalyptic doom and gloom, let's just take a deep breath because there is good news. These adversaries, these human or AI agents, will almost always first go for the lowest hanging fruit. And so if your tolling concession is reasonably prepared, while you might not be 100% protected from cybersecurity threats, your infrastructure will likely go unscathed simply because there is easier prey available. So don't be the easy target, I guess, is the message. Your job is not to be perfect. It's just to not be the easiest target. Because really, if you are, as stewards of public infrastructure, quite honestly, this is equivalent to negligence. So what is the solution? Audit your security on the entire stack with emphasis on the edge devices. Effectively implement identity and secrets management. Implement a zero trust policy across your infrastructure. Deploy proper security logging and vulnerability tracking tools. Have a clear and tested documented recovery plan that covers the entire stack, including edge equipment provisioning. Deploy secure remote access tools for those things that we need to bring data in and out from our environment to the outside world, to the internet. And finally, engage security experts that have deep knowledge and understanding of road user charging systems. And don't depend entirely on your incumbent monolithic technology provider. And with that, I want to thank you for your time and attention. I hope this has been useful for you. And if you have any questions or feedback, please reach out to us.